Hey y'all, welcome to Multiplying and Dividing Decimals with me, Brian. Let's get it started.
Hey everybody, let's jump right into multiplying and dividing decimals on the TEAS math course with me, your host, Brian. So at this point, we've done adding and subtracting, so let's get into the other two operations of multiplying and dividing, remembering that there are going to be different rules in this lesson. So our goal, we are going to be able to accurately multiply and divide decimals with differing place values without a calculator. We may not always have the luxury of having a calculator with us. I get that we have phones and all those other things, but there may be minutes when they are not available. So let's look at our key vocabulary. One, we have the word product, which is the answer to a multiplication problem. So as you see here, we do have a factor times a factor is equal to a product. So you may hear these words throughout. Product, no, we are not talking about some little gift that you might have gotten for someone that might have a cute bow on it. No, we're not talking about a product that you bought from any store. We are talking about the answer to a multiplication problem. Other key vocabulary words that are all related to the same idea. We do have the word divisor, which is the number doing the dividing, the dividend, the number being divided, and the quotient, which is the answer to a division problem. So if we took a division problem, let's say 317 divided by 4, and that was equal to something, our divisor, that's the number doing the dividing, would be 4. So our divisor would be 4. Our dividend, the number that is being divided, would be 317. And our quotient, which is our answer, would be right here. So I also may refer to these by their names. You may see them as their names. Just make sure you understand that that's what we're talking about. So some of our key points. If you're able to use a calculator, it may be different depending on which school you're applying to or where you're working. If you can use a calculator, great. But that's really just to make sure that the decimal points are going to be in the right spot. So today, I would try them fully on your own, see if you're able to do it by hand. Then you can double check with a calculator, see if your answer is correct. All right, for multiplication, we do not line up our decimal points. So in this case, you have 4 3/10 times, and then I'm just going to line everything up this way. Not line up by the decimal. You can see they're not lined up, but just making sure that the last digits of each number were lined up and what came next. We'll get into why we don't have to do this, but you do not have to do this for multiplication. Essentially, you'd end up having so many zeros if you made everything line up that you'd be multiplying entire lines by zeros. So all of your answers would end up just having entire rows of zeros. And we don't need anything to confuse us more than the work that we are doing. So then we're just going to multiply as if the decimals weren't there. So in this case, let's do 6 times 3 is 18. Drop the 8, carry the 1. 6 times 4 is 24, plus 1 is 25. So I'm going to cross this out. Then I'm going to add a placeholder 0 because that's what we do when we go to the next place value. So then I'm going to do 8 times 3 is also 24. Drop the 4, carry the 2. 8 times 4 is 32, plus 2 is 34. And then we're going to add all these pieces together. We get 8, 9, 6, 3. Now we're not done yet. We just showed that the multiplication is done like this. So we do have another step, but these are the digits that we are going to end with. So one of the key points to use is that however many numbers that are after the decimal in the question are going to be after the decimal in the answer. So here there is one number after the decimal, right? That's the 3. In the second number, we have 2 numbers after the decimal. So that means we add those together. So our answer will have 3 numbers after the decimal, making sure that what we mean by after means to the right. So we're going to start and we're going to go 1, 2, 3. put in our decimal point here, and in case it is not clear, our final answer will be 3 and 698 thousandths. Now, you may ask, why do we do this? And that's going to be a great question. So what it means is we pretended that instead of 4 and 3/10, we pretended it was 43. So that was like multiplying this number by 10. We pretended that 86 hundredths was actually just 86 because the decimal point was then moved twice out of the way. So that's really like 10 times 10, which is like times 100. So together, this problem is 10 times 10 times 10 times bigger than it should be, which means we made the problem larger by 1,000 times. So if we did that to pretend, we do have to do that at the end and make our number 1,000 times smaller. That happens by moving our decimal point once, twice, 3 times. So yes, it does work. It's not a trick, but we do pretend like they're not there, and then we just adjust to make sure it matches its original sizes. For multiplication, when you're multiplying by a decimal less than 1 whole, your product will be smaller than the other factors. So what does that mean? So let's look at some examples. We know that 4 times 1 is going to equal 4. That's something we all can understand. Next, we have 4 times, let's say in this case, 2. And that is going to equal 8. Now, what if I did 4, but I multiplied it by 0.5? You can put that into a calculator. That's going to give us the answer 2. We are so used to multiplication making numbers larger, but that's not always the case. In fact, it changes when we get to decimals. Because 0.5 is less than 1 whole, it will cause this number to be smaller than what we started with. This is going to be so important to remember when we get to percentages. Remember this idea because it's going to help you figure out, does my answer make sense? So hold on to that idea. Anytime you multiply by a number less than 1 whole, the number in the front will go down. All right, so we'll also talk about division. Know that we are going to go through sample problems, so if this is a lot, totally get it. One of the things is that we never have a decimal in our divisor. And remember, our divisor is going to be outside. That's the number that we're dividing by. Some of you may ask, why? Why do we do that? Well, if we had this, say, we had 4 and 4.5 on the outside, and we had 110.7 or 73 hundredths inside. You have a decimal here and a decimal here. Where would our decimal go in our answer? If we had 2 decimals in 2 different places, then it makes it really confusing to understand where our decimal points go in our answer. So instead, we get rid of the decimal point in the divisor. By leaving it inside, makes it much easier. So imagine this problem, again, a little different. And let's see if I can remember the same numbers. I think, by Scott, I think I did it. So if I actually had, let's say, instead of 4.5, I had 45, only having 1 decimal right here would tell me then to bring it straight up for our answer. So much easier for us to know what to do when we only have 1. Now, we also have to have that process of how do we even get there? What do? We focus first on our divisor. However many times we move the decimal to get it out of the divisor, we also do to the dividend. So, if we have to move this 1 time, because now it makes the number 486, we have to move it once as well here. Not twice, because remember, we're allowed decimals in our dividend, not our divisor. So if we were going to redo this problem and rewrite it, we would have 329 and 8 tenths and outside 486. Now, some of you may wonder, why does this work? Let's talk about it. So let me erase some of these things. if you need it, by all means. So if we'd looked, we really had 32 and 98 hundredths being divided by 48 and 6 tenths. Now, we first saw that we multiplied the number, the divisor, by 10. How did I know it was 10? Because we moved our decimal point one spot. And that allowed it to equal 486. Remember equivalent fractions. Equivalent fractions say that if you're going to want to keep the fraction worth the same amount, you have to multiply the numerator and denominator by the same number. This is just the fractional form of the division problem. So that means that I also have to multiply the number on top by 10, which moves the decimal point one time. Because we multiplied the numerator and denominator by the same number, they stay equivalent. So that's why it works. That's why we don't fully move the decimal point out of our dividend, because if we did, that would have been multiplying it by 100, and that's not equivalent to multiplying it by 10. All right, once the decimal is out of the divisor, we are just going to then divide normally. So we know that 486 does not go into 3, does not go into 32, does not go into 329. One of the things that I like to also do is from the beginning, or when I get here, is to make sure, not as a highlighter, but as a pen mark, that we are going to put our decimal point straight up. One of our guesstimations at this point, you may be able to guess, 486 is about 500. 3,298 is how I'm looking at it, is close to 3,000. So I'm actually going to try 6. One of the strategies, so that you don't mess anything up on the inside, is you can try it using estimation on the outside. So we are going to actually use 486 times 5. Remember, I do want an answer that's less than 329. Got a little too excited. So 5 times 6 is 30. Drop the 0, carry the 3. 5 times 8 is 40. Plus 3 is 43. 5 times 4 is 20, plus is 24. Now, I can assume that if I added 486 more, I could probably get a little bit closer. Yeah, that looks like it's pretty close for us. So that's going to be 6 times, I'll put the 6 up top, 2,916, 2, 8, 7. And then this is where we could keep going from here. I'm not going to have you keep going. I just wanted to show you that you would be able to divide exactly like normal. So also pay attention to problems. They may give you an idea of where you're supposed to go or how many place values you're supposed to go after the decimal. So when you are dividing by a number less than one whole, your quotient will be larger than the dividend. So let's look again. Let's use our same numbers. So if we did 4 divided by 1, we know that's going to be equal to 4. Right? That's something we know. If we did 4 divided by 2, which is what we're used to, we know that's going to be equal to 2. Right? We're used to division making numbers smaller. So 2 is smaller than 4. We know dividing by 1, it keeps it the same. Now you can think, what's going to happen now when we divide by a number less than one whole? So let's do 4 divided by 0.5, which we know is a half. Now, some of us may assume that it's 2 or may not be sure how to solve this. So if I was to take 4 wholes, 1, 2, let's assume they're all the same size. I can only be so perfect. 3, and then let's do the 4th one. If I was to split these in half, because it's asking how many halves are there, that's 1, 2, 3, 4, 5, 6, 7, 8. So 4 divided by 0.5 is actually equal to 8. If you noticed, 8 is larger than our dividend. Why did that happen? That's because we're dividing a number into not even one whole piece. We're doing smaller pieces than one whole, so we're going to end up with more than the wholes that we have. And that happens when we divide by a number less than 1. Again, this is going to be very important for when we get to percentages. Now, why do we do this? Decimal amounts are going to come up often, so we could be taking medication and putting it into doses, ordering exact measurements of items, determining price, and a ton of other scenarios that require the understanding of how to multiply and divide decimals. Again, calculators are great, but if we know how to do this, it'll reinforce your understanding of the math. So let's dive into some sample questions. One of the tips and tricks that we tell you to use, try the problem on your own first, hit pause, then see how we go through the problem. If you need to see a few, absolutely watch. This is your time. So we have 3 4/10 times 45 hundredths. Try this one on your own, pause it here. All right, so let's jump in. We know that we do not line up our decimal points, but I'm just going to line up the number of digits. It's going to make it easier for me to see. So 5 times 4 is 20. Drop the 0, carry the 2. 5 times 3 is 15, plus 2 is 17. Done here. I'm going to add in my placeholder 0 since I'm now done with the 5. 4 times 4 is going to be 16. Drop the 6, carry the 1. 4 times 3 is 12, plus 1 is 13. Remember, I'm now going to add these together. So that's 0. 7 plus 6 is 13. Drop the 3, carry the 1. 1 plus 1 is 2, plus 3 is 5. Bring our 1 here. Now, we knew, so reasonableness says that 3.4 is being multiplied by a number less than 1 whole, so our answer should be less than 3.4. That may give you a hint of where to put the decimal point. Great. But again, then we use our rule. We have one number after the decimal. That's the 4. In 45 hundredths, we have 2 numbers after, the 4 and the 5, which means our total will then have 3 numbers after. So we go 1, 2, 3. Now, you may see 2 options here. You may say 1 and 53 hundredths because this 0 does not hold any value. So know that you may see that, or you may see what we found. Both are absolutely correct. If you want one that is the most correct, I would put this here, but they're the same value. All right, sample question number 2. Again, we have decimals with differing place values. So we're not going to line anything up. We're just going to remember that we do have decimals involved, but not going to be our biggest deal just yet. All right, so we set up our problem, and then we just multiply like normal. So let's go for it. So 7 times 2 is 14. Drop the 4, carry the 1. 7 times 1 is 7, plus 1 is 8. 7 times 8 is 56. So I'm going to count that here. Now notice how I did not put any decimals in. That's because we're not there just yet. I'm going to put in my placeholder 0. 5 times 2 is 10. Drop the 0, carry the 1. 5 times 1 is 5, plus 1 is 6. And then 5 times 8 is 40. So I now get to add them together. That is 4, 8, that's 12, 6, 4. Now notice how both of our numbers here are both greater than 1 whole. So that means 8 and 12 hundredths is going to be, our answer is going to be larger than that number. Again, we use our decimal rule. Here we have 2 numbers after. 5 and 7/10 has 1 number after the 7. So that means in our final answer, we're going to have 3 numbers after. So in this case, 1, 2, 3. We have 46 and 284 thousandths, which does make sense. It is larger than 8 and 12 hundredths. And if you actually estimated and you took 8 and 12 hundredths, rounds to 8, 5 and 7/10 rounds to 6, that means our answer should be close to 48. And in this case, 46 is pretty close to 48. Sample question number 3. We have 0 and 34 hundredths times 0 and 585 thousandths. I know I mentioned before number of digits. Because this has more digits, I like to put that one on top. I like to not do too many placeholder zeros because then that can make it just a little bit messy and not the biggest fan of that idea. All right, so again, we just multiply like normal without lining up the decimals. 4 times 5 is 20, drop the 0, carry the 2. 4 times 8 is 32, plus 2 is 34, drop the 4, carry the 3. 4 times 5 is 20, plus 3 is 23. We're going to cross those out, add in our placeholder 0, and we continue because the 4 is done. 3 times 5 is 15, drop the 5, carry the 1. 3 times 8 is 24, plus 1 is 25. Drop the 5, carry the 2. 3 times 5 is 15, plus 2 is 17. Now we have all of our digits, so we can add them together. 0 plus 0 is 0. 4 plus 5 is 9. 3 plus 5 is 8. 2 plus 7 is 9. And we bring down our 1. All right, so now we do our thinking to see where does our decimal point go, and is our answer reasonable? Because 0 and 34 hundredths is being multiplied by 585 thousandths, which is less than 1 whole, we know our answer should be less than 34 hundredths. So we have 3 numbers after the decimal here. 1, 2, 3. And we have 2 numbers after here. 1, 2, which means if we put those together, we should have 5 numbers after. So we move our decimal once, twice, 3, 4, 5. We put our decimal point in front. Now, just for accuracy and lack of confusion, when we have this, we have these numbers here. This 0 did have to count for the place value purposes, but it has no value here. Also, for accuracy and to make sure that no one gets confused, we do put a 0 in the front of our answer. So I heard that is a great habit to get into for nursing, just to make sure that numbers are not misconstrued, that 0.5 doesn't look like the number 5, or that decimal points can't be missed. So get in the habit of, if there's no whole number in front, to put a 0 there. All right, sample question number 4. One thing I like to do, we have 56 and 8 hundredths, 56 and 8 tenths divided by 2 and 4 tenths. So one thing that we have to start here, if we look, we have to figure out which one is which. So if it helps you to set up your problem first, let's do 56 and 8 hundredths. I've said that again, 8 tenths, divided by 2 and 4 tenths. We notice that we cannot have a decimal point out here. So we do move this out one time. So our new number outside is 24. And we do the same thing to our dividend. So we have 568 divided by 24. And now we would divide like normal. So 24 does not go into 5. It goes into 56 2 times. 2 times 24 is 48. That gives us we subtract, that gives us 8. We bring down, we say 88. 88 divided by 24, that is going to be 3 times, because 3 times 4 is 72. Subtract, we get 16. So some of us may say, what do we do now? Well, unlike fractions where we say remainders, we can add a decimal point below, above, and we can add a 0. And we could keep going. So if we did 160 divided by 24, I'm going to say that that could be, it's 25. Let's try 6. So I'm going to try 24, and you may need this help on the side. So 24 times 6. 6 times 4 is 24. Now I'm seeing what number works so that I don't make a mistake. 6 times 2 is 12, plus 2 is 14. So that's 144. That's going to work. So that's a 6. We did all the work. Subtract. We get 16. We could keep going. Now I'm going to notice that I start to notice that a pattern is going to arrive every time, because if I did 6 times again, that's going to be 144. If I subtracted, I do get 16 again if I added a 0 and bring it down. So we could write it as 23 and 66 hundredths, 67 hundredths, depending on if it asked us to round. But you also might see something like this. That line above is just the repeating symbol. Because these 6s are going to continue on forever, instead of writing them on forever, this symbol lets us know that those do continue. Sample question 5. We have 812 divided by 36 hundredths. One of the things to think about is my answer going to be larger or smaller than this? We do notice that we are dividing by 36 hundredths. That is a decimal that is less than 1 whole, so it is the opposite of what we're used to. Division usually to us makes numbers smaller. In this case, it is going to make it larger. Now we start to make our adjustments. So if we set up our problem first, we have 812 on the inside, and we have 36 hundredths on the outside. We know that we have to get rid of the decimal on the outside, so we have to move it twice. That means that our new number on the outside is 36. Now, if you notice, there is no decimal point in 812. That's why we talked about knowing that the decimal point is at the end of the number. We moved the decimal point 2 places outside, so we still have to do the same thing. But if you notice, there's nothing above those, which means it's a perfect spot for placeholder zeros. So we put those in. And if you would like to remember where the decimal is, we do put it at the end. And now you just divide like normal. So 0, 36 goes into 81 twice. That is 72. We subtract, and that gives us 9. Bring down our 2. That's still going to be 72 again. So I'm going to put 2. 2 times 36 is 72. Subtract, we get 20. Bring down our 0. If I think 36 is close to 40, 40 goes into 25 times. So I'm actually going to try 5. And if I'm unsure about it, I can try it somewhere else. So 5 times 6 is 30. Drop the 0, carry the 3. That would be 180. I cannot get any closer. So 225. So then that's 180. Now notice I get 20 again. So that's probably a really great indicator that I've reached a spot where something is going to continue. If you want to check it out one more time, notice how again this is 5. 36 times 5 is 180. If you subtracted, you are going to get 20 again here. So if I brought down a 0 again, sorry for it squished, notice that we're just going to keep continuing with the 5s. So one spot is we do wait until we get to the decimal to say that it is repeating. So the way that you would see this final answer written would be 2,255 and 5 repeating. Right, we notice this 5 is going to continue on. That's how we notice it. You are allowed to do the repeating symbol as long as it continues. If your teacher said or your test tells you to round to the nearest tenth, you would have had 55 here. That 5 tells this 5 to become a 6. And you would have had 2,255 and 6 tenths. But just really pay attention to what is asked of you if you're supposed to round. And sample question number 6, this is our final sample question. So let's look at how we set this problem up. Let's mock it out. So that's 45 and 6 tenths, and that's 1 and 55 hundredths. Again, we have to move our decimal point once. Twice, we focus on the divisor first. So now our divisor is 155. And we still do the same thing to the inside. So that's once, twice. Again, we know the decimal point is going to be here. I am left with an open spot. That's a 0. So I have 4,560 inside with the decimal point going here. Now we can do our division like normal. So that's 0, that's 0. I know that 150 times 3 is going to get me 450. So most likely 2 is going to work. So how do I check? 155 times 2. If I'm guesstimating, that's 2 times 5 is 10 plus 1 is 11. 2 times 1 is 2 plus 3. Now some of you say 310 is really far away from 456. But if I added another 155 for 3, that'd be 465. And that's too big. So I'm going to add in a 2. That gives us 310. I subtract 6, 4, 1. Then I bring down my 0. So I have 1,460. I know that this is probably close to 10 times, but because we can only put one digit above, I'm actually going to try 155 times 9. So 9 times 5 is 45. Wrong one, excuse me. Drop the 5, carry the 4. Same thing, 9 times 5 is 45, plus 4 is 49. And that gives me 1,395. So subtract. And let's do 10 minus 5 is 5. 5 minus 9 I can't do, so I borrow the 3. Make the 5 15. 15 minus 9 is 6. And then 0, 0. Notice how I have 1. I forgot to put up here that we used a 9. Decimal point came straight up. And now we can add a placeholder 0 and bring it down, and we could continue our division. So in this, I did not give you explicit instructions, so let's do one more round before. But again, please pay attention to what is actually asked. If it asks that you have to go to the tenths place, you do need 2 places after the decimal. Whole number is just 1. Whatever it asks you to round to, you do have to go to one more place. So 155, that gives me 465. And if I added 155 again, let's check. This is my way of checking 5 times. That's 0. That's 12. That's 620. So in this case, that is 2, 3, 4 times. So 4 times 155 is 620. Subtract, we get 30. And we could add another 0 and keep going. For the sake of this question, I am going to stop. Again, please pay very specific attention to what the questions ask you. All right, now it is your turn to go try out multiplying and dividing decimals using all the rules that we talked about. Again, remember, you do not have to line up the decimal points when multiplying. The number of decimals after the amount of numbers after the decimal in your problem are the amount of decimals after the amount of numbers after the decimal in your answer. For division, you cannot have a decimal in your divisor. However many times you move the decimal out for your divisor, you do the same thing to your dividend. You got it. Just practice. Make sure you fully understand if your answer makes sense before you hit submit. But you got this, and I can't wait to see you for the next lesson. Have a good one.
Y'all, that was wild, but congratulations on crushing another lesson here at Nurse Hub. You should be proud and then continue working to make sure you fully understand everything that you just watched. Remember, practice is the only thing that we need to make ourselves better at all of these topics. Good luck, and I hope to see you soon.